Trigonometry is one branch of mathematics that found a lot of application in design and engineering. You're welcome to Dynamic Educational Hub channel. This is a channel where I dissect various topics in physics, chemistry, and maths. And if this is your first time of coming across my channel, kindly subscribe to my channel and click on the notification icon to get notified when I release a new video. What are we learning in this video? We are going to start learning trigonometry. Being the first video in this playlist, we start by learning the basics of trigonometry. Alright, without further ado, let's start.
The first thing I will advise you to do before you learn trigonometry is learning Euclidean geometry. And I have on my channel, I have playlists for learning Euclidean geometry. Just learn the basics of Euclidean geometry. It's going to assist you in understanding trigonometry. So now trigonometry is a branch of mathematics that studies angles, and the father of trigonometry is Hipparchus of Nicaea. So when we are talking about angle, finding expression for angle, finding the function of angles, everything is embedded inside trigonometry. So the first thing we would like to learn is angles. What is angles? Angle is formed by intersection of lines. Angles range from 0 degree to 360 degree. You can have angle that is more than 360 degree. So any angle that is more than 360 degree is a multiples of angles between 0 degree and 360 degree. For instance, 720 is a multiple of 360. So traveling around a circle, complete circle is 360 degree. So anything that is beyond 360 degree means that you are adding whatever angle again, you are adding in 360. For instance, 380 degree is still equivalent to 20 degree. Just subtract 360 from it, then you can get a 20 degree. That's the concept of angle. Angle can be more than this. Angle can be measured in degree, radian, and pi. Now let's quickly look at examples of angles. Here I have a reflex angle. Now if you look at this, we have opposite angles here. This is an acute angle, this is a right angle. So let's learn types of angle within few minutes. Types of angle. So let's start with acute angle. Acute angle is an angle that is less than 90 degrees. We all know this. So which means if we are reading an angle starting from 0 degree as shown, so any angle in between 0 degree up to 89 degree, 89 point something degree, so we have acute. Any angle in between this range is still acute angle. Just look at it. Now when it reaches this 90 degree, it becomes a right angle. So don't forget, right angle is an angle that is equal to 90 degree. So after 90 degree, any other angle that is greater than 90 degree becomes an obtuse angle. Obtuse angle is an angle between 90 degree and 180 degree. So we have obtuse angle as shown. So it increases until it reaches 180. Any angle that is more than 180, we call it a reflex angle, and is in between 180 to 360 degree. So let's look at measurements of angles in radian. And what is radian? Radian is a convention for measuring angle, the units of angles. This angle can be measured in degree, pi, and radian. And what is radian? Radian is a measurement that is based on when the length of an arc of a circle is equivalent to the radius of that circle. So what is radian? Measurement of an angle that is based on the angle subtended by 2 radii of a sector with length of an arc equal to its radius. So let's have a circle here, and let's form 2 radii as shown, and we have the sector over here, which is the minor sector. Now these 2 radii is going to subtend angle, and these 2 radii is forming a sector with the length of an arc shown here. Don't forget sector. Sector is a shape that is formed, a plane shape or part of circle that is bounded by 2 radii and an arc. So I have a playlist on circle geometry. You can go ahead and watch that playlist. Watch the video under the playlist. Now, radian now means that we want to measure an angle in between these two radii in which the radius will be equals to this length of an arc. That is what we want to do. And let's see how to do that. And if we measure that angle, we are going to get 57.3 degrees. This is an angle in which the radius will be the same thing with the length of an arc. If you move starting from a point and you move anti-clockwise or clockwise, the angle at which the length of the circumference of this circle, which is the length of an arc, will be the same thing with the radius. That is radian. Now let's see how to get this 57.3 degrees. Now remember that we know that the length of an arc will be equals to the radius. So that is what we want to use. Don't forget from measuration the formula to find the length of an arc. Length of an arc is theta over 360 degrees multiplied by 2 pi r. So if you do this, multiply theta with 2 pi r, what are you going to get? We get 2 pi r theta over 360 degrees. That is the length of an arc. Now this length of an arc is equals to the radius. So we can equate this with the radius. So let's equate it. It means that 2 pi r theta over 360 degrees is equals to the radius. And if you cross multiply, you can get 2 pi r theta is equals to 360 degrees. Is that okay? So the next thing is to make r or theta the subject of formula. So we cannot make r the subject of formula. R we cancel r. So the next thing is to divide both sides by 2 pi r. So let's divide both sides by 2 pi r. Dividing both sides by 2 pi r, what are we going to get? Or dividing both sides by 2 r theta. Dividing both sides by 2 r theta, what are we going to have? So we have 360 degrees divided by 2 r theta. Don't forget that 2 r theta will be gone here, so we'll be left with pi here. Divide this one by 2 r theta, so we have 360 degrees over 2 r theta. So you can divide this one by 2 here, 2 here, 2 in 360 degrees, we have 180, and then we have r theta. So which means that pi here is equals to 180 over r theta. And if we make theta subject of the formula, so which means that we are going to bring down this pi down here. Just this one is making pi subject of formula. This one, let's make theta subject of formula from here. Making theta subject of formula, you are going to divide both sides by 2 pi r. Dividing both sides by 2 pi r, we get this. So we still get 180 degrees over r pi. Now go ahead and substitute the value of pi into this equation. So which means that 180 degrees divided by pi, you can press your calculator. 180 degrees divided by pi, we are going to get approximately 57.3 degrees. Or you divide 180 degrees or 180 divided by 3.143, the value of pi, you are going to get 57.3 degrees. That is how we get this angle. At this angle, r will be length, and you can verify that, and you can practicalize this, and you will confirm it that the angle at which the length of an arc will be the same thing as the radius will be 57.3 degrees. You can do a practical then to verify that. Now we have verified that we can convert angles to radian and pi. Let's see for pi. Here we have r theta under, so which means that pi is equals to 180 degrees in radian. For this angle here in radian, 1 degree is equals to 57 points. Now we can see that 1 radian is now 57.3 degrees. So if you are now talking about radian, you see that we've measured this angle, and the measurement we now give it a convention which is radian. So which means that this 57.3 degrees is now, we now call it 1 rad, 1 radian. So that is radian that we used to use in solving questions in engineering and in mathematics. So this is where it is derived from. So this is the convention. 57.3 degree is now equivalent to 1 radian. So we are now using this convention to convert angles. If you want to convert degree to a radian now, 1 degree will now be the same thing as 0.01745 rad. Just go ahead and find the inverse, the reciprocal of this. Just divide both sides by 57.3. So you are going to get 1 radian divided by 57.3, and you are going to get this. So 1 degree is 0. And looking at here, 1 degree is equals to pi over 180 degrees. Since we say that pi is equals to 180 degree, pi is equals to 180 degree, so it means that 1 degree will now be what? Pi over 180. So that is all about angles in radian and in pi. So we can convert angles to pi and we can convert it to radian. So let's quickly look at the summary of what we have learned in measurement of angles in pi and radian. So we see that pi is equals to 180 degree in radian. Master this. Which means that 2 pi will be what? 2 times 180 degrees. So which means that 360 degrees is equals to 2 pi in radian. And 1 radian is what? 57.3 degree. Finally, we can see that 1 degree is pi over 180 in radian. So you can be asked to convert angles to pi. To do that, since you know that 1 degree is pi over 180 in the radian, so you will just multiply pi over 180 degree, multiply by that angle, then you can get your angles in pi. So you are not going to substitute the value of pi there. But if you are asked to convert degree to radian, you are going to put the value of pi, which is 3.14, approximately 143, divided by 180. So when you do that, you get 0.01745 rad. So 1 degree is pi over 180 in radian, and 1 degree is also what? 0.01745 in radian. So this is how to. Now let's see how to convert angles. Now we have examples here. The first example is convert the following angles to radian and pi. Wow. So we want to convert it to radian, purely radian, and we also want to convert it to radian in pi. That is the meaning of this. Now the first one is 150 degree. Let's see how to solve it. We know that 1 degree is pi over 180 degree in radian, which is still the same thing as 0.01745 rad. What angle do we want to convert? 150. So it simply means that 150 degree will be what? 0.01745 rad multiplied by 150 degree, and that will give us 2.6175 rad. To convert it to pi, we know that 180 degree in radian is equals to pi. So which means 1 degree is pi over 180 in radian. So 150 will now be what? 150 multiplied by pi over 180. So you just go ahead and pick this 150 and multiply it by pi over 180. So which means that to convert angles to pi, you just pick what? Pi over 180 degree multiplied by that angle. So you can reduce this to the lowest fraction. Now 0 will cancel 0 here. You are left 15 over 18. So 3 can go in 15 5 times. You have 5 here. 3 can go in 18 6 times. So you now have 5 pi over 6. So in angles, that is how to convert it to pi and radian. So let's quickly solve the second question, which is 45 degree. Now we see that 1 degree is equals to pi over 180, and it is what? 0.01745 rad. So 45 degree will be this multiplied by 45. So 0.01745 rad multiplied by 45, and when you do that, we get this answer. And in the same way, 180 degree in radian is pi. So to convert, don't forget this formula. You multiply your angle, you multiply it by pi over 180, or you simply put your angles with pi divided by 180. So 45 degree will be your what? 45 degree over divided by 180 degree. So degree cancel degree, 45 in 45 1, you are left with pi here. 180 divided by 45 get 4, because 45 multiplied by 2, that's 90. How many 90 do we have in 180? We have 2. So 2 times 2, 4. We now have pi over 4. So 45 degree is also pi over 4 in radian. And 45 degree is equals to what? 0.7875 radian.
Now, I believe you can convert angles to radian and to pi in radian. So I have a quiz for you. Go ahead and solve this question, answer it, and comment your answer in the comment section. And if you haven't subscribed, kindly subscribe to this channel, click on the notification icon, share this video, like this video. And next video, we are going to look at important theorem in mathematics. All right, thank you for watching this video. See you in the next video. Bye for now.